Hey guys, welcome back. I'm gonna show equivalence point now. Real quick, I want to fix an error. I had 13.18 here. I don't know why I did 14 minus 1.82 and I said it equaled 13.18. It equals 12.18. So if you guys were confused, yeah. Anyways, let's find equivalence point now. So equivalence point is when the moles of acid equals the moles of base. So basically they have the same concentration of each is the same in solution. Is same in solution. So in the previous ice tables, I've been actually writing stuff down for H2O, but it's a liquid. So that was kind of like wrong on me because they have activities of 1, but I just was like kind of not paying attention to the fact that it's a liquid and writing it down. But you don't really have to do that when you guys do it, okay? So let's find out what our initial concentrations are at the equivalence point. So in order to do that, we're gonna have to know how many mils of base were added, right? We know it's gonna be somewhere between 25 and 30 because that was when we had our shift and we realized, okay, now we have more base than acid, right? So the way we do that is actually kind of simple. So if you guys know, molarity is moles over liters, right? And volume is liters, or it could be milliliters, however. These cancel out and give us moles. So if we do the molarity times volume of acid, and then we multiply it by the molarity times volume of the base, what's going to happen is that the base's molarity, which is also moles over liters, it's going to cancel out with its volume, and then we'll have moles equal to moles. So what we can do is put the molarity of acid, which is 0.1 in this question, and then the 25 mils of base. Since it's mils on both sides, I don't have to change to liters. That's just an example of how units of volume cancel out. Now here we can put the molarity of our base, which was 0.087, and we're going to find the volume, which is what we wanted, right? We need the volume in order to find the pH. So we need to find how much base was added. So when I do this, I get 28 mils. So that makes sense because it's between 25 and 30 here. So now that we know it's 28 mils, we can do our dilution because like we said, these are, it's 20 mils of base added, but we need to find out how that affects the molarities. So we know the molarities will be equal, but we have to know what they will be, right? So let's use our molarity problem now. So our dilution equation, I mean. So we have 28 mils of base alone, and then the molarity of it is 0.087. Then our new molarity, which we're looking for, is going to be multiplied by the volume of 28 plus the volume of the acid it's being mixed with, which is 25. Let me just put it all in one straight line. 28. Oh, okay. I don't know what's going on with the pen. One sec. Oh, wow. Okay. Okay. Can this please stop? Okay. Sorry. Okay, so 28 plus 25. Okay. All right, now that I'm M2, we can find that finally. So we have 0.0459 for this molarity. And it's going to be the same because we already found out this is the equivalence point, right? So we know our acid and our base are going to have this molarity. Cool. So let's find out how much salt we made. So we're losing reactants and we're gaining products, salt and water. We'll just like ignore water because its activity is 1. So 0.049 minus x, which x is going to be 0.049, by the way, guys, because there's no limiting reactant anymore. They're equal. So they kind of wipe out each other. So these equals 0 equals 0. And this guy is 0.049. Now, a lot of you guys were saying, like, do we use, well, we know that we have to use this equation, right? CO initial minus X, but is it KA or KB? Well, what you have to do is look at your salt. Is this a basic salt or acidic salt? This is a basic salt because look at this. This we can ignore. It's coming, this cation is coming from a strong base. We always ignore cations and anions from strong bases or acids, but this is from a weak acid. Because it's from a weak acid, it means it's a basic salt. That's how you can tell if you need to do Ka or Kb. So we're using Kb because it's basic salt. If this was a titration with a weak base plus a strong acid, they would actually give acidic salt, and then you would use Ka. Okay, so that's the difference, right, between these two titrations. Honestly, this example I'm showing, the titration with the strong base, is way more common from my experience. So what goes here is the question now. Well, what's left in solution? It's only, I mean, well, there's equilibrium going on here, right? But what's actually happening is our basic salt is providing our pH. So our basic salt is actually what's dissociating. It's kind of giving off some basicity, right? So what's happening is we're always going to put our salt concentration here, always salt concentration, no matter if it's acidic or basic. If it was a neutral salt, you wouldn't even do this because the pH at the equivalence point would be 7. You just have to find the volume, right? But we're talking about acidic and basic cases here. So I'm gonna make some room. Now we can solve. So I'm gonna put in the 0.049. And we're going to neglect x, okay? Because, yeah, we're just going to neglect it, and then we can check our approximation later. I already know our approximation's fine to make. You guys can check it on your own. So now that we know we're using Kb, we need to find Kb, right? So the equation for finding the conjugate base of an acid, so this is the dissociation constant of our acid. This is the dissociation constant of its conjugate base. So they equal 1 times 10 to the negative 14, which is Kw, the dissociation constant of water. And this is an equation you just have to memorize. So the way we're going to find Kb is by putting in our Ka, which is 1 times 10 to the negative, I already forgot this, -5. So cool. Now, according to this, our Kb equals 1 times 10 to the negative 9. Okay. So here now we can put 1 times 10 to the negative 9. So if we solve for this here, I'm sorry it's getting messy, guys. I don't want to delete stuff until I know I don't need it. X equals, let me think. Okay, X equals 6.77 times 10 to the negative 6. Now, this is another important step. What you do to X here depends on if you used KB or if you used KA. Okay, so we used KB, which means our X is the concentration of OH. So this X, once you take the negative log of it, it's going to give you POH. And then you do 14 minus the POH equals your pH. But if we were doing a weak base strong acid titration, we'd be using Ka. So whatever X equals, you just take the negative log of that. So X will equal a number, and then you take a negative log of that, and that'll equal negative log of the number, and that'll equal your pH. So I'm going to create a summary of this at the end. I'm just explaining it as I go as well. So the POH here would be 5.169. Plug that in here, and your pH becomes. This has been a long video. The pH becomes 8.8. And indeed, that's a basic pH. So it's a basic salt, it makes sense. So this was basically the titration of a weak acid and a strong base. It's going to give us a basic salt. And that's why we use KB. And that's why at the end we get a POH when we take the negative log of X. So I'm actually going to clear everything and just make a summary of just what happened. So for finding equilibrium point at strong base plus weak acid, what we did right now, Rn. Equilibrium point of weak base plus strong acid. So I guess we don't need those underlines, or I guess I'll put them. So first here, what we did is we found the volume. We found the volume, and we did that by using this equation. MV equals MV, but here is acid and here is base. And you do the same for the first step on the other one as well. MV equals MV. Acid. But the difference is that in this one, we were looking for the volume of base added, but this one, we're going to be adding strong acid. So we're going to look for the volume of strong acid added. So the problem will give you different things. In this problem, we weren't given this. And in this problem, we won't be given this. So, but it's the same concept, right? It's just being able to apply it. I recommend practicing, but honestly, this one on the left is more common. After we find our milliliters, we do a dilution. And that's what we've been doing this whole time, right? We've been doing a bunch of dilutions. So because it's the equilibrium, man, I literally cannot type today. Equivalence point, because it's that, it doesn't matter if you solve it for the acid or the base. Like, it really doesn't matter. Acid or base, it doesn't matter. Just choose the one that you feel comfortable using. I choose, like for this one, I personally like to choose base because that's what I'm working with, and I like to focus on what I'm working with. This one I like to choose acid because like the salt's acidic, which by the way, let me put salt will be acidic. pH will be acidic at equivalence point. Less than 7. Salt basic. So pH will be more than 7 at equilibrium point. So the third thing is you basically set this up. You put x squared over concentration of your salt after like your salt's made, right? Minus x. So you're gonna take basically, you're straight up gonna take this molarity 2 and plug it into here, right? Because the concentration of base or the concentration of acid, whatever it is, it's gonna push all the way, and you're gonna have the same concentration of salt. So like, remember, we had minus x, then we have plus x. That's because all the x goes here. So whatever this molarity of base is, it'll end up being our concentration of salt. So hopefully that makes sense. So, so same thing here. Take this molarity 2, and you're gonna plug it in for this here. And then, but the difference is here. This is gonna equal Kb because the salt is basic. This is gonna equal Ka because the salt is acidic. Now we neglect our x. We find our x by just solving the way we have been. So now you found x. Take the negative log of x. It's going to equal your POH. So now you have to do 14 minus POH, and it's going to equal your pH. This last step's a little shorter because you can just take the negative log of your x. It's going to equal your pH. So that's it, guys. Let me know if you have questions, concerns. If you saw me make a mistake, let me know, because I make them a lot. So thank you so much. See you guys later. Okay, bye.